So, hi everybody. The objective of today's session. This is kind of a two-part series of talks. So feel free to stick around and check out Connor's talk after this talk, and feel free to check all the other ones out too. Luis is giving a talk right now as well that you should definitely go and watch the VOD of because that'll be a great talk. So what we're going to start with, we're going to talk about a little bit about what Nix is and how you can use it on Replit, and kind of a high level, and then we're gonna build a bunch of things with Nix on Replit, and then Connor's going to be talking about what the more in-depth details of how Nix works and how you can contribute to Nix packages and all that kind of stuff. So to start with, I'm Zach. I am a platform engineer here at Replit. I've been here for just over a year and a half. When I started, I did a lot of work with Polygot, which was the solution that we had come up with to the problem of languages on Replit before Nix. And lately, I've been doing a lot of work on building Nix templates and migrating existing languages to Nix. So we're gonna start out with a poll real quick. You can go ahead and go into the poll section. How many of you have created a Nix REPL on Replit? Could have been in the last couple days. Could have been back when Nix first entered beta, and you haven't touched it since. Just any kind of Nix REPL. So we'll wait and see what the polls are. Actually, a lot more people than I was expecting. It's going to make the next slide seem a little strange then, but we'll make it work. So what if I told you that all REPLs are actually Nix REPLs? If you've made a REPL on Replit in the last month and a half to 2 months, depending on which language it is, you've made a Nix REPL. Nix is the environment, it's the package manager that powers all of our languages on Replit these days. So, okay, that's cool, but what does that mean? What is Nix? What does it mean that all of our REPLs are powered by Nix? And to understand that question, we have to kind of understand what Nix is and what the problem that it's trying to solve is. So fundamentally, I mean, Nix is a lot of things, and Connor will talk about that in more depth. But fundamentally, Nix is a package manager. And a package manager is a piece of software that keeps track of all of the files that are associated with other pieces of software. So if you can think about like Discord. Discord is an application. You can download a Debian package for it. And if you download that Debian package and look into it and actually inspect it, you'll see there's all of these files. There's these user bin files, and there's these binaries, and there's some shared libraries, and all of these files that are distributed with Discord. And when you install Discord, what you do is your package manager takes that packaged set of files and it extracts them onto your machine. It dumps them all into the same place as all of the other files from other packages. That's not entirely how it works, but at a high level, that's how it works. You've got this big bucket of files from all of your packages, and you install a package by dumping files in there, and your package manager will keep track of which files belong to which packages and deal with installing new packages or removing old packages. The problem with that is everything is kind of there at the same time. It's just this one giant system state. And what that means is if you have two packages that both have different dependencies, maybe they both have the same files in them and they're poorly structured packages, or they both depend on like some version of libc or something like that, where you have two separate packages that depend on the same thing. If one of those packages updates, then you might get into a situation where the other one breaks because the first one updated. And that can be very difficult to track down what's going on, because the thing that broke was not something that you touched. It may not even be something that has an explicit dependency on the thing that you updated. And that makes languages and language tooling very difficult, because a language, if you think about what a language is in terms of like, using a programming language, yes, you're writing code in that language, but what you're really doing when you use a programming language is using the tools for that language. If you're using Python, you're using the Python interpreter to run Python code. If you're using C, you're using Clang or GCC to compile C code. And all of those are packages. All of those are tools that are distributed in some kind of package. And all of them have their own implicit dependencies, and all of them have their own system state that they expect. And what that means is if you try and use a large number of them at the same time, you can get into really delicate situations where you have some packages that depend on one version of a library and some packages that depend on another version of a library. And we get into this situation where if we update one version of a package, we update Node because people are saying, oh, the version of Node that you guys have is really far behind. And in updating Node, maybe we accidentally changed a dependency that Node had, and that broke Ruby or something like that. That was our first attempt at languages. It was called Polygot. It was a massive 40 gigabyte Docker container, Docker image that had all of the languages installed in it. There was this awful JavaScript templating thing that generated shell scripts that installed all of the languages that we wanted to support. And it was an absolute bear to maintain, because if you changed one dependency, if you installed a new version of a package, you would break something else that was totally unrelated. We had an issue at one point, a little over a year ago, where we had updated some Java version and it totally broke VNC REPLs because the VNC version wasn't pinned and there had been an upstream regression, and it was a mess. So anytime we tried to update Polygot, it was this delicate balancing act of making sure that nothing broke. And it made it virtually impossible for us to accept community contributions to Polygot. Like, we would love to be able to accept community members adding more languages or adding more tools. It was just not something that we could do because of the nature of Polygot. And so we ended up with this big backlog of pull requests, and it just wasn't working anymore. We were spending more time not breaking Polygot than doing new things. And so we said, okay, how do we fix this problem? Our main goals were, we want to have builds that don't break. If we build a new set of language tools, we don't want to break existing REPLs. We don't want changing one language to break another language. We don't want to have to worry about unexpected upstream dependency changes, just breaking everything. And ideally, we would want to be able to accept or work with community contributions. And Nix was something that fit all of those criteria. And so we get back to what is Nix. And Nix is a package manager. It's a package manager that is designed to keep every package separate. So you don't have to worry about all of those things. When you build a Nix package, it's built in isolation. There's no dependency conflicts because it's built with all of its dependencies. If you have multiple libraries, they can all coexist. And it has a fantastic ecosystem of packages that you can contribute to super easily. It's super easy to open a pull request to Nix packages and add new packages. So okay, well that seems pretty cool. That's what Nix is, but how do I actually use it on Replit? Why does it matter? So the first way, we're going to talk about a couple ways to use Nix on Replit, but the first way is probably the simplest way, and that would be just to make a Nix REPL. So we're going to go in here, we're going to make a Nix REPL. And a Nix REPL is really just a blank REPL. It's an empty REPL. Like I said, every language uses Nix, and we'll get into how that works later. But for now, we're just going to make a Nix REPL. And so, okay, great. Now I have a Nix REPL here, and you'll see that there's a couple of files over here. There's these config files. There's a .replit file and a replit.nix file. And the first one we're going to look at is replit.nix. And you can see replit.nix specifies a list of packages to install in this REPL. And in this case, we just installed the program cowsay, and cowsay is just a program that makes a cow say things. So, we may want a different program. Maybe we're in the mood to play Risk, right? So the board game. So we're going to hop over here to the Nix package search. And I'm going to search for Risk board game. And if I search for the Risk board game, I find this package here called Domination, a game that's a bit like the board game Risk. Okay, well, let's try that. So we're going to install this package into our REPL. And we just do that by adding it to this replit.nix. And when we go over here to this console, it's going to detect that I have made changes and reload my Nix environment. And if I run the command domination now, it's installed. And now I have a Risk clone that I can play on Replit. I can go in here and play a new game, whatever. And that's pretty cool. I can just install anything. It just is there. Anything that's on Nix packages, I can install. I can install like Blender or some music tools or anything like that. It's all just there. But this is still kind of clunky. Like, I have to go in here, if I want to use domination, I have to go in here and I have to run the command. I have to remember what the command is called. That's a pain. So I can go into this .replit file, and I can specify this run command. And this run command is just a command that's run when you click the run button. So I can put domination in there. And now if I click run button, it's just going to run the command. Don't have to worry about typing it in the console. Don't have to worry about any of that. It just works. It even works in Spotlight view, because the run command just updates the run command just specifies what happens when you click the run button. So if you click the run button in the Spotlight view, the command runs. And so we have our REPL that's now running a program just through the run button that we installed from Nix packages.
Hey, Zach, we've got a question. So, you installed this package and then you're able to run it like really quickly. It didn't seem like it downloaded anything. So how does that work?
So because that package was on Nix packages has a cache of all of the packages that are available for installation. And you can download packages from Nix packages, but because the way that Nix packages, or because the way that Nix works, where every version of a package is independent, we can actually pre-download all of them and save them on your local machine or on the machine that's running your REPL. And when you run a program, we just have to grab it from a cache already that we already had populated. So let's take this a step further. Is my audio glitching out? Everybody
just a little
hear me
bit.
Okay? Might take a second. Any better now? Might give it a second, see if I can't change my resolution. Here, I can turn off my video. Am I any better now with my video turned off?
Yeah, sounds better to me.
We'll wait and see here. Okay, cool. Yeah, all right, perfect. We will do that. So, okay, we have a REPL that we created, runs risk when we click the run button. Can we do something more useful? And the answer is yes, we can. We can use that run button to run tools for a programming language. So we can make a Go REPL here. And if we make a Go REPL, it'll load up. And this is just a normal Go REPL, hello world. I can, import format, print hello world. If I run the REPL, it runs Go run. And it'll run hello world in a second here. There we go. And we got hello world. But a Go REPL is actually a Nix REPL in disguise. If we show these hidden files, we can see there's a .replit file and there's a replit.nix file, just like when we made our Nix REPL. And the replit.nix file has the Nix packages for running Go programs, Go version 1.17 and the Go language server. And we can go look at our .replit file. And the .replit file, it just specifies a run command. When you click on the run button, it runs go run main.go. So if you click run, it runs that command. So now you can configure this REPL to do anything that you want. If you wanted to, it doesn't have to be a Go REPL. I could turn this REPL into something else by changing the run command. Maybe I change this to Lua main.go and I install Lua. And now I click the run command and it's not going to work because main.go is not a valid Lua command, but it tries to. So Lua is installed and now we effectively have a Lua REPL. So does this mean that I can build my own language with Nix? Because if all a language in Nix is a combination of a replit.nix file and a .replit file, then isn't it possible to just make my own? Just grab stuff out of Nix packages and make my own language. And you absolutely can do that. So we're going to go ahead and hop back to the home page and we're going to make a new REPL. And we're going to make another blank Nix REPL. And we're going to explore this possibility using the Octave programming language. So Octave is a numeric programming language. It is similar to MATLAB if you've used MATLAB before. And we're going to use it just because it's a language that we have never supported on Replit before. It's a brand new language. We have never built any infrastructure specifically for this language. So the first thing that we're going to do is we're going to go into our replit.nix file, and we're going to install Octave. We're going to do that just like we installed all the other programs by just adding it to the list of dependencies. And now I can go over here to the console, and it's going to detect a change. And now I have Octave installed. Now Octave is going to open up a graphical window because sometimes you can draw a plot with Octave, and that's where that plot's going to pop up. But you can see down here in the corner, we have an Octave session. I can write invalid Octave code. I can set variables. I can modify variables, and we've got Octave running. So, okay, that's kind of useful. It's not useful necessarily by itself. We probably want to have some kind of main file so that we can persist our code. Working in an interpreter is a bit of a pain sometimes. So we're going to make a main file, and I'm going to copy paste some code in here. And this is just code from the Octave documentation. This will generate a 3D plot. And now I can go down here to the console, and I could run that code like I would in the console. And if I run that code, I've got to add the persist flag. That just tells Octave not to shut down because it's displaying a graph. And so now I have a graph. And so, okay, now we're getting somewhere. We've got a main file.
You ran Octave, and then it just magically opened this new pane that shows the output. So how does that work?
So one of the things that we do in all REPLs is when you run a program, that if that program tries to render things to the screen, if it tries to connect to the display port or the X socket, we'll detect that and we'll actually spin up a remote desktop connection to your REPL. So if you open any graphical program, it will detect that you're trying to draw graphics, and it will open up that remote desktop connection, and you'll have your graphical program, just as though you had run it on your local machine. So we have this Octave session that's running now. And, this is great, but just like before, it's kind of a pain to have to type stuff in the terminal, in the console, and remember what we got to type and all that. So we can jump into our .replit file, and we can go ahead and update our run command. And we're just going to update the run command to say the exact same thing that we typed in the console, since we know that works. So we're going to say Octave. We want to persist. And we want to run main.m. And now if we click the run button, main.m. There we go. We're doing pretty good on typos so far, all things considered. And so now we have a REPL that is a lot closer to a environment for programming MATLAB. Vim keybinds are in the settings. You can set somewhere. Yeah, there you go. Keybinds Vim. There's also Emacs, but you don't need that. So we've got an environment that's a lot closer to a MATLAB or an Octave style environment on Replit. But there's still a couple weird things. You notice that even though our program is done running, the run button hasn't come back up. It still says stop. That's not really ergonomical. We don't want to have to hit stop and then hit run again. And if we hit stop, our graph goes away, and that's kind of a pain. So what we're going to do is we're actually going to treat this program as an interpreter instead of as a program, because we're not really running Octave. What we're doing is interpreting it. We have a script. We want to run through that script, and then we want to do other stuff. And so to do that, we're just going to make a change here to our .replit file to tell Replit that this command is actually an interpreter. Now, because it's an interpreter, sometimes it will run with a file, and sometimes it will run without a file. So instead of listing our file in the command, we're going to separately tell Replit that the entry point for this REPL is main.m. And we're going to do one other things that is up in this three dots menu, hidden files. So we're going to do one other thing. We're going to add a file called .octave.rc. And this is just going to let us configure the Octave prompt. The way that we detect when an interpreter has finished running code and has become a interactive session is by looking for a prompt. So we're just going to add this to the Octave configuration that renders our little Replit prompt down here. So if I go up and click run now, you can see we've ran our code. The run button has gone back to run, and we have a little prompt down here. But this prompt is actually a Octave session. And even more interesting than that, this prompt is actually the same Octave session that ran the code before. So if I set a title, you can see my prompt or my graph updated. So I can interrogate all of the variables that were set in my script. I can change the labels of things. It's the same session. So okay, well that's pretty cool. I've got a REPL that's pretty close to a live interactive Octave environment. So let's talk about getting this public. Let's publish this, make a template out of it, let other people make Octave REPLs on Nix. So what I can do here, the last thing that I probably want to clean up is, you notice we got a lot of stuff on the side. And that's kind of distracting. There's a lot going on there. So we're going to clean it up a little bit. We can get rid of this Nix README. And now this Octave RC and Octave Workspace, they're not really relevant to running like Octave code as a user. So we're going to drop into this .replit file, and we can just go ahead and add those files to the list of hidden files. So we don't need to see Octave RC, and we don't need to see Octave Workspace. And now I can hide hidden files just to make sure that worked. And there we go. So now we have a REPL. It's got a main.m file. When you click run, it runs it. You've got an interpreter. That's a pretty complete Octave experience on Replit. So let's go ahead and publish this. Let's make this a language that other people can use. So we're going to go ahead and name this Octave Nix, because this is Octave with Nix. And then we can go up here and we can publish this REPL. And we're going to publish a template. And this template publishing flow is a feature that we're going to be releasing in the near future, so keep an eye out for that. And I'm going to set an icon, and this is going to be on a separate window. We're going to go ahead and set the Octave logo. And Octave is a numeric programming language. And I can go ahead and publish this template. So, okay, I've published this template. Let's go ahead and head back to the Replit homepage real quick. This might take a second to load, so we'll go ahead and add a refresh in there. But if I go create a new REPL now, and anybody can go and do this. Right now, you can go and create a new REPL, and you can search for Octave, and it will be there. So you can all go create new Octave REPLs just like any other language. It took 15 minutes from making the Nix template to having a public language on Replit. So that's one of the things that you can do with Nix. You can build new environments for any programming language that's on Nix. But you might ask, what if my language isn't in Nix packages? What if my language is some obscure language or doesn't have a Nix package yet, and I still want to use that language on Replit? Well, we can still support that. We just have to add that package to Nix ourselves. And we make that really easy to do. We've got some templates that you can use to get started there. And so to demonstrate this, I am going to add the Bazel language to Replit. Now, Bazel was the programming language that won our programming language jam. And we're going to go ahead and add this as a Replit template. So the first thing that we're going to do is we're going to make a new REPL. And we're going to use the Nix derivation template. And this will be our, Bazel derivation. This is going to create a new REPL with an extra file in it called default.nix. And this default.nix file is going to be a Nix derivation. Now, Connor's going to get more into the specifics of how derivations work. So we're just going to look at them at a very high level here. But the idea is we have some set of inputs that we use to build this derivation. And then we have some set of commands that we use to build it. And then the output is the files that are in the package. So we're going to start by changing the name. This is going to be for Bazel. And then the source isn't going to come from a local repository, or the source isn't going to come from a local folder. It's actually going to come from GitHub. So we're just going to use this Nix command to download some code from GitHub. Now, because we're using this fetch from GitHub, I have to make sure that I include that in my inputs so that Nix knows what I'm using. And then this owner and repo and revision and SHA all refer to the actual source code that we're grabbing. So we're going to pull this revision, which is just the latest commit from master. This SHA is the contents of that commit, or that of the repository at that state. That way Nix knows that we're always building with the same environment and with the same input. And so we know, if we have the same input, we should have the same output. And so that allows Nix to keep track of that. Then the next thing that we're going to do is we're going to need to build Bazel. And so if we hop over here to the Bazel documentation, we can scroll down and we can find the build command. So to build Bazel, we're going to run this build script, and we're going to run the Bazel release command. So we can go ahead and add that in our build phase. Now, we're going to need Python. So if we want to use a Python build script, we're going to need to add that to our inputs, but we're not going to need Clang anymore. Now, to build our Bazel binary, we're going to need to look in the Python 3 package, and then we're going to get bin Python 3 out of that package, and we're going to use it to call build.py, which is going to be grabbed from the GitHub repository, and then we're going to run the Bazel release command. And that'll give us a binary or a bin directory in our build directory. So then we just need to copy that to the output directory. So we'll go ahead and make our output directory and then copy the bin directory into the output directory. Now I can click run, and run is going to build this derivation. It's going to download the source code from GitHub. It's going to compile it with the compiler in the standard environment. And this is going to take a minute. And once it's done, it's going to produce a result directory. And you can see it's already made the folder, or made the file. So after a second, there we go. We have a result directory. If we take a look in that result directory, we have Bazel. So I can go into this result directory, and I can actually run Bazel help, and I've got Bazel version 1.0.0. So now I can take this derivation, and I can submit it in a pull request to Nix packages. Now, we've done that already. We haven't submitted it to Nix packages. We've submitted it to our overlay, but you can see it's exactly the same. We make a derivation, we name it, we set the source, we set the build command, and we install it. So now we have Bazel installed in or added to our Nix packages. So now we can use Bazel in any Nix REPL. Now that doesn't mean that Bazel is an official language yet. It just means that it's available as a binary. So let's see how we would turn that into a proper language. So just like before, we're going to make a template. We're going to name it Bazel. Or we're going to make an empty Nix REPL. We're going to name it Bazel. Now, we're going to go into our replit.nix, and just like before, we're going to install our package. Now, this is because this was installed in our overlay. This is a replit package. But we can install that just the same. And if we go into our console now, we run Bazel help. We have Bazel version 1.0.0. So now I've got Bazel. It wasn't, 5 minutes. Well, yesterday it wasn't on Replit at all, and now the binary's on Replit, and all it took was a pull request. So okay, we've got Bazel. Let's use Bazel. Well, the way Bazel works, first we're going to need a main file. So we'll go ahead and add main.bazel. And I've just got a quick hello world over here. So we'll add hello world. We can go ahead and delete this README. And now we can go over here and we can Bazel, Bazel main dot Bazel, and that runs. So let's wire up our run button now to do that for us. So we don't have to remember to type it in the console. Bazel main.bl. And now if we click run, we have a Bazel REPL. So now this REPL runs Bazel. So let's make it live. Let's make it an official language on Replit. So we're going to click on publish. We're going to go to template. We'll set the icon. We'll jump over here and grab the little blurb and add that to our description. And we will publish this REPL. And now we'll give it a minute, although by the time I get back to the home page, we will probably be good to go. And if we make a new REPL, we can search for Bazel. And there we go. Bazel is now a language on Replit. You can make a Bazel REPL. Makes a new template. There's our hello world. We click run, and it works. So we're 35 minutes in, and we've added 2 new languages to Replit. So let's keep it up.
Here.
Maybe I don't want to build a programming
Yeah, we can maybe answer a couple questions here. So, yeah, Toby asks, how does the interpreter command know to load the entry point file?
So that is determined by the infrastructure that runs your code. So you tell Replit, here is the interpreter command, here is the entry point file. And then Replit goes, okay, you've specified an interpreter command. When you click run, I'm going to take the entry point file and give it to the interpreter command. And when your REPL boots up without clicking run, I'm just going to run the interpreter command. Yeah, so the packages.replit packages is just because for today's demo, we didn't upstream Bazel. We just added Bazel to our set of packages. We have a extra set of packages that we build on top of the upstream Nix packages. And so we added Bazel to our overlay. So ideally, we would upstream Bazel to the public Nix packages, and then you would just access it by saying packages.bazel. Do we have any other questions?
Someone asks, is it possible to install VS Code or Eclipse with Nix?
It absolutely is. In fact, I'm just going to go to this REPL here, and I'm going to run Codium. No sandbox. Now, Codium is not installed in this REPL, but we know what package contains Codium, so we can install it from that package. We figured it out automatically. And hey, now we have VS Code in a REPL. Just like that. Didn't have to even install anything. If you wanted to use Eclipse, I suppose you can use Eclipse. We'll specify, we'll try and run Eclipse. It'll ask us where we want to install Eclipse from. We'll run Eclipse and VS Code at the same time. And there we go. Now we got Eclipse. So anything that is on Nix packages is accessible from a REPL. We could get, I'm sure we could get, what else we got? Atom in there as well. Why not? Get all the text editors. Okay. So what if I don't want to build a programming language? And this is where things start to get really interesting, because all of the primitives that we build on Replit are not necessarily code primitives. They're just computing primitives. Anything that you can do on a computer, you can do on Replit. And that includes not code things that still use text editors and running commands. And so to take a look at what that might look like, we are going to build an environment for editing LaTeX documents on Replit. LaTeX is a typesetting format. It's used a lot in research papers and reports and that kind of thing. So we'll call this LaTeX. We'll go ahead and make a REPL. And just like before, we're going to hop into our replit.nix file, and we're going to install the tools to build LaTeX documents. Now, because LaTeX is a notoriously big piece of software on the order of many gigabytes, it's not just a simple, .latex. We can actually go to our search page here, and we can search for LaTeX, and we'll find, actually, I think it's called TextLive. Yeah, there we go. So this command is actually textlive.combined.schemeful. So that's going to install all of the packages for TextLive. So we'll go ahead and add that there. And, if we go to our REPL, it's going to detect a change and install it. And it's going to take hours to install because it's a huge piece of software that TextLive is. Okay, well, that was supposed. There we go. It's done. So we have everything cached. We didn't have to download anything. Totally good to go. So now we can make our actual text document. So we'll just say main.text. And I've got just a super basic example here. This is just an empty document that says, welcome to LaTeX on Replit. And we'll run PDF text and main.text. And it's going to build a PDF. And so there we go. We're compiling LaTeX on Replit. But, this is not very ergonomic. Obviously, the first thing that we want to do is what we've been doing with all the other packages and update the run command. So we can say run equals, we're going to say PDF LaTeX main.text. And now we're going to add an extra command in here just to make sure that if there is an error during typesetting, it doesn't try and keep going and mess things up. So we click run here, and we will build our PDF document, and we have an updated PDF. We didn't change anything, but we rebuilt the PDF. But this still isn't a great experience. We have to switch back and forth between our PDF and our source code. And while, yes, we could open them in different tabs and switch back and forth between the tabs, I guess we can open them in different tabs. Oh, yeah, there we go. Yeah, we can open them in different tabs and switch back and forth between tabs, but we still have to switch back and forth. We can't see them at the same time. So it's still a bit of a pain. Is there a way that we could handle viewing these PDFs differently? And we can reuse some of the infrastructure that we intend for previewing hosting to do that. So what if, instead of viewing this PDF document in the editor, what if we viewed it in a web server? We could host it as a web server and then view it in our web server preview. So we're going to install a web server here, https, and I can go ahead and run this in the console. And oh, it did not. There we go. Did I spell it wrong? Oh, I got to have packages. All right, 2 typos in 40 minutes, pretty good. So it's going to detect my new environment, and if I run https, it's going to run a web server. And now you'll notice we detected that there's a web server running, and automatically forwarded the ports and set everything up, and now we have this web preview. And we can go over here and we can actually view main.pdf in there. And so now we can kind of look at them side by side. it's still not super ergonomic, but we can build on that. Let's go into our .replit file now, and let's make it so that, we'll move this out of the way for now, and we'll make our run command http://lz. So now when you click run, it'll run the web server. But that means we won't compile the PDF anymore. We won't build the PDF. So we're going to turn this run command into a compile command. So compile commands are ran before run commands. And now when I click run, it will compile my PDF and then run the HTTP server. And okay, now we're getting somewhere. But it's still kind of a pain. Every time I run it, I've got to go over here and click main.pdf. That's really a pain. I don't want to have to deal with that. So what if instead we built just a little bit of infrastructure into our template? We can have an index file because a web server, it serves the index. And maybe in this index, I can put a bit of HTML that all it really does is draw a iframe. And that iframe contains our PDF. And if I run again, well, look at that. Now our index renders the PDF. And because this is a file that we control as part of the template, we could put whatever we want in here. We can add a div, put it in the footer. Maybe we want to add a button to download the PDF. And we can add whatever buttons we want to add in this preview. Now we have a download button. We could add, if we wanted to, we could wrap some or put some JavaScript on there that calls to a web server and live reload when your PDF updates. All you would do is just build a web server in your REPL and add that code to the HTML. And so now we have LaTeX on Replit. Now, there's still the issue of the stop button. We've got to stop it and then run it again. I'm a little behind where I want to be, so I'll show this real quick. I'm going to add a runner script. And these runner scripts are a really nice pattern. You can actually go look at the template for Python Turtle. Python Turtle uses a runner script as well in a kind of a cool way. So what we're going to do here, this runner script is just going to kill the web server if it's already running, and then start a new instance of the web server. And it's going to start it in the background so that the run button can go back to green. And I'll just update our file here. And instead, we're going to run runner.shell. And if I click run, now I have my PDF. It's updated. I can click the run button again. It refreshes. And we have PDFs on Replit. I will have links to all of the REPLs. Yeah, I will have links to all of the REPLs too at the end. So okay, well now this is really cool. We're getting somewhere. Let's turn this into a template. We've got a whole bunch of extra files on the side. So just like we've been doing with all of our other files, we could add a hidden here. So now we've got these hidden files, and now we're looking a lot closer to a proper LaTeX editing environment. But let's take it one step further, because LaTeX it's kind of hard to write. Like, there's a lot of syntax errors you can make. There's a lot of macros. Like, it would be great if we had some kind of autocomplete. But, Replit has never had LaTeX support. So how could Replit know how the autocomplete for LaTeX works? And that's where the language server comes in. So a language server is a tool that provides context-aware advice for a programming language. So we're going to look for a LaTeX language server, and we're going to find one here from TextLab, or called TextLab. So we're going to unhide our files, and we'll go back to our replit.nix file, and we're just going to go ahead and add this to our REPL. So TextLab. And then we've just got to tell Replit to use this file. So we can go in to our .replit file, and we're just going to say, all right, hey, Replit, I've got a new language for you. It's called LaTeX. LaTeX files, they look like this. They're in any directory, and they end in a .tex. And if you see a LaTeX file, then you're going to start the language server by running the command textlab. And that's it. If I go back to this main.tex file, I can make a section, and now I have autocomplete. Maybe I want to begin. What can I begin? Oh, I can begin an abstract. There we go. Oh, but I got an error. What is this error? Oh, it's a mismatched environment. That's right, because I forgot to end the abstract. And now my error goes away. So now we have language server. We have warnings. We have autocomplete. We have everything that you need to edit LaTeX. So let's ship it. We have our hidden files. Our hidden files are updated. So we can go ahead and go over here and publish this REPL. And we can, I don't have an icon for LaTeX. And I can go grab the blurb from the LaTeX website. All right, well, I'm going to have glacially slow internet. So we will just say LaTeX is a program for typesetting beautiful documents. And I'll publish that. And there we go. Now you can edit LaTeX on Replit. Just make a new REPL, search for LaTeX, and you're off to the races. By the time we get back to the home page, we'll make a new REPL. Search for LaTeX. And there we go. Now we have a LaTeX REPL. All we've got is main.tex and our PDF. If I run it, we'll get our rendered PDF. And in fact, I can even go to the Spotlight page if I want to share this REPL. And if I run it in the Spotlight page, hey, look, there's my PDF. Because it's just serving a web server. So, okay, that's super cool. But I'm not really into scientific writing. I don't want to write research papers. I've more enjoyed writing interactive fiction. You know, I played Zork. It was fantastic. It inspired a lifetime of writing interactive fiction. Well, all right, let's do that too. Let's hop on over to Nix and maybe we search for interactive fiction. And here we go, Inform 6, an interactive fiction compiler. So we'll make a Inform REPL. And just like before, we're going to add Inform 6 to our packages. And we're also going to add Frotz, which is a runtime for what this Inform 6 compiles. And I'm going to make a new REPL or a new file, and we're going to call this main.inf for inform. And we'll just copy paste a quick hello world in here. Now, Inform REPL or Inform has a two-step compilation process. So we're going to have to use that compile command. So we're going to say when you compile an Inform REPL, you run inform on main.inf. And then when you run an Inform REPL, you run, what was the name of that? Frotz. Frotz on the output, which is main.z95, I believe. That was Z5. And so now I run this REPL, and hey, look at that. We have another language. We'll add a hidden file real quick here. So we're just going to hide all of our Z5 files. We'll double check our hidden files. And all right, well, there we go. Let's publish another REPL. And we got one last cool thing to look at with this. So Inform is a language for programming interactive fiction. So we'll go ahead and publish this. We'll hop back into our home page. We're going to make a new REPL. There we go. We're going to search for Inform. And now I have a Inform story that I got from the Inform documentation that was written in 1975. So we'll go ahead and upload this file. And then I'll go ahead and rename it just so that it was as if we had written this in the REPL. And now I have, if I click run, I have an interactive story. But even cooler than that, this is a REPL, which means we have a Spotlight page. So now I can go to the Spotlight page and I can run my REPL. And there's my story. I can look around. I can examine the house. Oh, well, let's go into the house. Let's eat the food. And now I have an environment for building and sharing interactive fiction, all built on Replit. You could share this for a friend. They can play your game. They can see how it works. In fact, here, I'll even share this in the chat. And you all can go and play that game. All of that was built with Nix and Replit in the course of an hour. I've got other things made with Nix, but we ran out of time. There's a whole bunch of stuff that you can make with Nix. We're in the process of a template jam. If you build a template on Nix, reach out to us, mention us on Twitter, add us, and if it's a good template, I believe there are prizes. We'll get it published on Replit. We want to see more templates. We want to see cool templates. We want to see people doing cool stuff on Replit that they've never thought of before. So that's the end of our time. We've got a couple minutes for questions, and by a couple I mean 2, and then Connor is going to be taking us through the details of how Nix works. And we can stick around for questions after Connor's session, or take things offline as well if people have more questions. Got to read through the chat. I'm not caught up. Alrighty. Well, thank you, everybody. I believe we moved to a different room for Connor's session. If you are staying with us for the second part of this series, the best way to have issues or to get help if we have issues with Nix. The deep dive is in a separate room. Connor, do you want to grab the link to that room? So the best way to get help if you're having issues with Nix. The Nix documentation is not great. We're in the process of trying to help build some better documentation. So we're going to be publishing a blog post that's kind of a more getting started with Nix later this month. So definitely keep an eye out for that. But other than that, probably the best way is going through. I don't know, Connor. What do you think the best way to unstick yourself on Nix is?
Sorry, what was that question again?
What's the best way to get help if you're having issues with Nix?
You can probably go to our Discord, ask us questions. I'll be in there. Yeah, Nix, like the hardest thing with Nix is there's not a ton of really great documentation. I think it's improving over time. But yeah, we're happy to answer questions, and we're also trying to like produce more content that makes it a little easier to get into Nix.
Hopefully the goal is that Replit is the place to go to get into Nix, because it's super easy to write. Like writing a derivation, the first time you write a derivation, it's a pain to figure out where you even put it. So having, this Nix template that you can create a new derivation at is a fantastic way to get into it. Yes, I believe we are migrating to the new session. Connor posted the link for the new session. So we will see everybody that's sticking with us over there at the new session. And if you are going to a different session, then I hope you all enjoyed it, and have a great rest of your day.